Module 1, Unit 1, Science and Science Education. Science education at the elementary level is fundamental in shaping how students perceive and interact with the natural world. Understanding the essence of science is the starting point. Science is about observing, analyzing, and investigating to understand the natural and physical world. It focuses on explaining natural phenomena through systematic study and evidence-based processes. Educational initiatives now emphasize conceptual understanding and student-centered, inquiry-based learning, as outlined in the Next Generation Science Standards, NGSS. These standards guide educators on what and how to teach to ensure high-quality science education. A key characteristic of science is its focus on the natural world and the premise that natural events occur in consistent, comprehensible patterns. Science is a process for producing knowledge base on systematic study, which can be modified in light of new evidence. Clarifying scientific vocabulary is crucial because terms like theory, fact, and argumentation have specific meanings in science that differ from everyday usage. A science lesson typically focuses on explaining the natural world, relies on evidence, involves testable ideas, and uses scientific behaviors. It incorporates questioning, investigating, and observing, aiming to make sense of these observations and using new knowledge to make and test predictions. The role of a science teacher is to help students develop progressively more sophisticated explanations of natural phenomena, guiding them to build on their existing knowledge and think critically about scientific concepts. Inquiry-based learning is essential in science education. It involves students in actively engaging with scientific questions and conducting investigations to derive explanations based on evidence. This approach helps students develop a deeper understanding of scientific principles and processes. Planning for inquiry instruction involves selecting appropriate science concepts, procedures, and skills. Teachers use curriculum maps and guides to create coherent content storylines, ensuring that each lesson builds on previous knowledge. Cross-cutting concepts are integral to understanding science and engineering. These concepts connect disciplinary core ideas and help students develop a coherent scientific worldview. They are essential for fostering a deep understanding of science rather than being the primary focus of lessons. Cross-cutting concepts include recognizing patterns, cause and effect, and understanding systems and system models. Effective pre-planning for instruction follows a sequence, selecting learning goals, developing learning targets, and creating a content storyline. This ensures that lessons are aligned with standards and build towards clear, measurable outcomes. Scientific inquiry requires abilities such as asking questions, planning and conducting investigations, and developing evidence-based explanations. Teachers must understand and apply science process skills to guide students effectively. A positive classroom environment is crucial for fostering inquiry learning. It involves creating a safe, supportive space where students feel comfortable engaging in scientific exploration. This includes planning for safety procedures and managing student behavior to ensure a conducive learning environment. Teachers design learning centers to present inquiry-based investigations, motivating and guiding students while meeting individual needs. Understanding science with depth involves more than memorizing facts. It requires the ability to explain, interpret, and apply knowledge. Students construct their understanding based on age, experiences, and prior knowledge. Teachers can use a variety of approaches to lead students to deeper understandings, addressing alternative conceptions through a conceptual change model. Incorporating the 5E model, engage, explore, explain, elaborate, evaluate, supports science learning by engaging students intellectually and leading them to explanations based on evidence. Each phase of the model involves different types of student interactions, from group work to individual activities, ensuring a comprehensive learning experience. Effective questioning is at the heart of teaching and learning science. Different types of questions are needed at different stages of the 5E model to move learning forward. Open-ended questions encourage deeper thinking and verbal development, while closed questions assess factual recall. Teachers' responses to questions guide learning and classroom discourse, supporting conceptual change. Assessing science learning involves both formative and summative assessments. Formative assessments provide ongoing feedback during the learning process, helping teachers adjust instruction to meet students' needs. Summative assessments evaluate student learning at the end of an instructional period. Performance assessments measure understanding of multiple learning targets, while large-scale assessments inform school and district-level changes. Unit 2. Getting ready for inquiry instruction. Getting ready for inquiry instruction is a critical step in ensuring that science education is both effective and engaging for students. This process involves several key components, starting with the alignment of learning goals to standards. Learning goals identify what students should know, understand, and be able to do at their grade level. These goals provide a clear framework for instruction and ensure that teaching is focused and purposeful. When getting ready for instruction, teachers must first select the science concepts, procedures, and skills they will use during inquiry learning. This selection process is crucial as it determines the content and skills that students will engage with during their inquiry activities. Pre-planning for instruction involves using units of instruction, curriculum maps, and guides, along with a variety of resources to create content storylines. These tools help teachers organize their lessons in a logical sequence, ensuring that each lesson builds on previous knowledge and leads to deeper understanding. Familiarity with the aspects of doing science, such as process skills and practices, is essential prior to planning inquiry-based instruction. Teachers need to understand the scientific method and the various practices involved in scientific inquiry, such as asking questions, planning, and conducting investigations, and developing evidence-based explanations. Determining the appropriate type of investigation in which to engage students is dependent on the question that is asked. Different types of investigations, such as descriptive, classificatory, experimental, and modeling, are suited to different types of scientific questions. When students are engaged in argumentation, they should be able to decide which of two explanations is better supported by evidence, use logical reasoning in presentations, identify claims and support them with evidence, and collaborate with peers to find the best explanation or solution. Argumentation involves discussing and debating scientific ideas, using evidence to support claims and reasoning logically, which helps students develop critical thinking skills and understand the nature of scientific inquiry. Cross-cutting concepts are fundamental to understanding science and engineering. These concepts help students connect different disciplinary core ideas and develop a coherent scientific worldview. They are necessary to develop a coherent scientific view of the world and are similar to previously identified unifying concepts and processes. However, they are not the primary focus of science lessons, but are integrated throughout the curriculum to support students' understanding. Learning goals should identify what students should know, understand, and be able to do, ensuring that lessons are focused on clear, measurable outcomes. The recommended sequence for pre-planning for teaching and learning involves first selecting learning goals to include, then developing learning targets, and finally creating a content storyline. This sequence helps teachers organize their lessons effectively and ensure that each lesson builds towards a comprehensive understanding of the subject. Scientific inquiry requires a variety of abilities, including asking questions, planning, conducting and communicating about investigations, and developing data-based, evidence-based explanations. However, using the scientific method is not necessarily a required ability for doing scientific inquiry, as it refers more broadly to the practices and skills involved in scientific investigation. In the context of teaching the disciplinary core idea PS2.B, which focuses on gravitational force, a fifth-grade teacher might use a descriptive investigation This type of investigation involves observing and recording data about a natural phenomenon, such as how objects fall towards the Earth's center due to gravitational force. Descriptive investigations help students develop observational skills and understand scientific concepts through direct interaction with natural phenomena. Teacher candidates should know and understand science process skills because these skills appear in some current state frameworks of science standards, are assessed on some certification exams, and are useful tools for accomplishing inquiry tasks during the practice of science. However, there is no single accepted list of science process skills, making it important for teachers to be familiar with a range of skills and practices. Throughout the process of inquiry-based instruction, teachers should guide and focus student activities, use their knowledge of their students to inform instructional decisions, encourage student learning, and use their knowledge of how students learn science concepts. For the full development of science proficiency, it is necessary for students to be actively engaged in the practices of science, exposed to developmentally appropriate instruction and materials, and provided with a range of instructional approaches. These actions ensure that students have multiple opportunities to engage with scientific concepts and practices in ways that are meaningful and appropriate for their developmental level.